I welcome you in this lecture. In this lecture, I am going to talk about the introduction to operational research. This is the third lecture on this introduction. The content of this lecture is methodology of operational research, definitions of various terms involved in the linear programming, formulations of a linear programming problem. First point is methodology of operational research. The major phases of an OR study are as follows. First is formulation of the problem. So basically in this article we are going to study the steps involved in the OR study, operational research study, and this is the phase 1 or step number 1 in OR study. It is the formulation of the problem. In this step the problem is formulated in appropriate form, and this phase should give a statement of the problem, and that includes the controllable, that is a decision variable, the uncontrollable parameters, restrictions or constraints on the variables, and the objectives for defining a good or improved solution. So this is the phase 1 of this operational research study. So in this phase we should get the statement of the problem, and that statement of the problem should consist of these 4 terms, that is a decision variable, uncontrollable parameters, constraints, and objectives for defining a improved solution. Second phase is the model formulation or constructing a model. In our study it is usually a mathematical model. Okay, so whatever the model is formulated, it is in the form of mathematical equations. A mathematical model consists of a set of equations which describe the system or problem. So as I said, this mathematical model consists of a set of equations. This equation represents these two things. First, effectiveness function, which we called it as objective function. Now remember that this objective function is related to either profit or cost. If the profit is there as a function, effectiveness function or objective function, it has to be maximized. If objective function is related to cost, then it has to be minimized. And the second point that equation represent is the constraints, and this constraint is generally corresponds to limited resources, and that may be limited availability of raw material or the limited time for which machine is available for the production. The objective function is a mathematical expression of the cost or profit. So as I said, objective function represents either cost or profit in the form of mathematical expression. And the constraint, or which we call it as restrictions, are a mathematical expression of the limited resources, such as manpower, materials, money, equipment, and space, etc. So we know that there has to be some restriction, because it is obvious that this manpower, it is limited. Material available, it is always limited. It has some restrictions. Money also, it has some restrictions, as well as equipment available and space available, always it has some constraints or restrictions. So these restrictions like this are represented in the form of mathematical expressions, which we call it as a constraints. And the last point, the objective function and constraints are the functions of decision variable. So the objective function is also a mathematical expression, and it it is formed by decision variables, and constraints are also formed by decision variables. So both these objective functions and constraints are formed with the help of decision variable, and thus it is said that both of these are the functions of decision variables. Now let us see the general form of a mathematical model which is formed in the phase number 2. So first is we have to identify the objective function from the problem statement, and this is the way this is represented. So this objective function is represented like this, either maximize or minimize. Objective function is denoted by z equal to f into bracket x1 x2 dash 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 xn. So this f represents, it is the function of x1 x2 xn, and which is subjected to constraints gi into bracket x1 x2 dash 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 xn less than or equal to, comma, equal to or greater than equal to bi. So here this gi represents the constraint equation, and it is the function of this x1 x2 xn. Then these are the three types of notations are used in the constraint equation. So this less than equal to or this greater than equal to is a inequality in this constraint equation, and if equal to sign is used, it is termed as equality in constraint equation. So like these constraint equations are represented, so there may be two or more than two constraint equation present in the problem statement. And this x1 x2 dash dash xn, which is present in this objective function and also in constraint equation, is nothing but a decision variable, and it is always greater than or equal to 0. So let us see this. What is this x1 x2 xn? It is a controllable, or we call it as a decision variables. So in a OR problems, this is actually a output for a decision maker. So output of a problem which is solved using OR technique is nothing but the values of x1 x2 xn. So it is called as decision variables, and based on these decision variables the decisions are taken. Then this function of this decision variable is called as objective function or effectiveness function, which is either maximized or which is to be minimized. If it is a profit, if this function represents profit, it has to be maximized. If this function represents cost, it has to be minimized. And if you get the maximum value of profit or minimum value of cost, it is nothing but the optimal value. So optimal value represents the maximum value of profit or a minimum value of cost. Then this gi, which is the function of this again decision variables x1 x2 xn, is nothing but the ith constraint. So I represents generally a number that may be 1 2 3. If this number is 2, we can say that there are two constraints. If this number is 3, we can say that there are three constraints. Okay, so this last term is bi, which is on the RHS of this constraint, that represents the limited resources, and these resources available are uncontrollable. Okay, so we cannot control this parameter, that is resources, which are limited, and thus it is used in the constraints, and I is 1 2 dash 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 m. So as the summary of this general form of mathematical model, we have seen that first is the objective function, which is either to be maximized or minimized, which is represented by letter z, which is the function of a decision variable x1 x2 xn. Second is the constraints. This constraints is again, it is the function of x1 x2 xn, and it is used along with the either less than or greater than equal to type of inequality or equal to equality. On RHS, there is a bi term which represents the limited resources, and x1 x2 xn are the decision variables, which is the output of OR problems, which is to be find out after solving the problems, and on which the decision is depends. Now the phase number 3 is deriving the solutions from model. So this problem, the mathematical model which is formed in the phase number 2 is solved by using mathematical calculations for obtaining the solution, and the solution consists of the values of decision variable. That means whatever the objective function that we have seen in the phase number 2 along with the constant equations, after solving that mathematical model, we get values of decision variables, that is the values of x1 x2 xn. Now the next is the phase 4, testing the model and its solution. Now this phase of the study involves the checking the validity of this model. Okay, whatever the model we have formulated in the phase number 2, and that model we have solved in the phase number 3, we have solved this model. That means we have calculated the values of decision variable x1, x2, xn. So this model is tested in this phase number 4. And testing the model is nothing but the checking the validity of the model. A model is said to be valid if it can give a reliable prediction of the system performance. If the model can able to predict the performance of system, then we can say that this model is valid. Now phase number next 5, controlling the solution. As soon as the one or more of the controlled variable changes, the solution also get changes. Sometimes this change in the variable is such that the solution may go out of the control. So we have to check that if the values of variable are changed, then what is the effect of solution, effect on solution. So therefore the method must be developed to find out the limits of variable within which the solution is reliable. That means what is the limit of variable that we can change from lower to higher value, that is lower value of variable to the higher value of variable for which the solution is reliable. That we have to find out by using certain methods. Now next phase is implementing the solution. Now this phase of method deals with the implementation of the tested results of the model. And this means that the careful explanation of the solution to be adopted and its relationship with the operating realities. So basically in this step, the solution which is obtained in the previous phases is explained for the current problem, and we should have the good relationship with the operating realities or operating system. Now let us consider the second article in this video. It is definitions of various terms involved in the linear programming. So the term that we are going to discuss in this lecture are like what is meant by linear, what is meant by programming, what is meant by constraints, what is meant by objective function, what is meant by non-negativity restrictions, like this, because these terms are required in the next article. Let us consider the first term, that is linear. The word linear is used to describe the relationship among the two or more variables which are directly proportional. So two or more variables are, if are directly proportional, we can say that it is a linear term. For example, if the production of the product is proportionally increased, the profit will also increase proportionally, and then it is a linear relationship. But in our case, this linear programming case, this linear term indicates the mathematical expression type. That is, the equations that we are going to use will be the linear equations. For example, let us consider this equation a1 x1 plus a2 x2 plus dash 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 an xn. This is nothing but a linear equation. Such type of linear equation we are going to use in the linear programming problems, where this a1 a2 are the constants and x1 x2 are the variables. More specifically, this x1 x2 xn are the decision variables. Second term is the programming. The term programming refers to the planning of activities such that to achieve some optimal result with resource restrictions. So basically this programming indicates the activities plan or planning of activities. A program is optimal if it maximizes or minimizes the objective function such as profit, cost or sale. So in the first statement I have said that this term programming refers to the planning of activities such that it achieves some optimal results. But what type of results we can say that it is an optimal result? So that result we can say that it is an optimal result if that result gives us the maximum value of profit or minimum value of cost or maximum value of sales. If that result gives such maximum value of profit, minimum value of cost or maximum value of sales, then that result we can call it as an optimal result. Third term is a decision variable. Decision variable describe the quantities that decision makers would like to determine, and thus it represents the output decision. The output of operational research problem is to find out these values of decision variable, because on these values the decision maker takes the decision. Next is objective function. The linear programming problem must have a well-defined objective function for optimization. For example, maximization of profit is a objective function. Minimization of cost is also a objective function, or minimization of total elapsed time of the system would be also a objective function. It should be expressed as a linear function of the decision variable. So the third definition we have seen is the decision variable, and also we have said that that decision variable is the output of the operational research problems. That means ultimately after solving the operational research problem, we have to obtain the values of decision variable, which is represented by the letters x1, x2, x3, xn. And this objective function must be the function of decision variables. That is, the objective function must be the function of decision variable like x1, x2, x3, xn. Now the next term is constraints. There are always limitations on the resources which are to be allocated among the various activities. Because we know that always the resources are limited. That may be the raw material, that may be the manpower, that may be the space, that may be the money. Okay, so always there is a restriction on the resources available. These resources may be production capacity, manpower, time, space, or machinery, as I said. These are expressed as linear equalities or inequalities in terms of decision variables. So in the general form of mathematical model, we have seen this constraints that was represented by gi into bracket x1, x2, xn bracket complete less than equal to comma equal to greater than equal to bi. So that means these constraints are the equations, linear equations, either with equalities or inequalities. An inequality may be of type less than equal to or greater than equal to. And last is non-negativity restrictions. So this non-negativity restrictions indicates whatever the decision variables we have calculated after solving the mathematical model, that values are always non-negative. That is, these values of decision variables are always positive. So all the variables must assume a non-negative values. That is, all the variables must take on values equal to or greater than equal to 0. Therefore, the problem should not result in negative values for the variables. That means the values of decision variable is always positive or it is equal to 0. Now, next article is formulation of linear programming problem. So in this article, we are going to see the steps which is required to formulate a LPP problem, that is linear programming problem. The formulation of the linear programming problem, which is termed as LPP, as a mathematical model involves the following key steps. Step number 1, identify the decision variables to be determined and express them in terms of algebraic symbols, that is x1, x2, x3. So in this step number 1, we have to identify the decision variables from the numerical statement or a problem statement, and we have to give them notations as x1, x2, x3 likewise. Step number 2 is identify the objective function which is to be optimized, that is maximized or minimized, and express it as a linear function of the above defined decision variable. In the step number 1, we have to identify the decision variable. We have to give the notation to this decision variable as x1, x2, x3 likewise. And in the step number 2, we have to identify the objective function, and we have to represent this objective function in the form of these decision variables. Step number 3 is to identify all the constraints in the given problem and then express them as linear equation or inequalities in terms of above defined decision variables. So both these objective function and constraints are the functions of this decision variable. That means both this objective function and constraints are represented in terms of decision variable, that is x1, x2, x3, xn. And step number 4 is non-negativity restrictions on the decision variable, that we have to mention here that whatever the decision variables we have considered in the step number 1 are either greater than or equal to 0, and it indicates that these decision variables are never negative. These decision variables are always positive. So these are the 4 steps which are required to formulate a LPP, that is linear programming problem. So with this article we have completed this lecture. If you have any doubt, you can ask in the comment section.